Hello, this is Mario from Audion. In this video, we will talk about using the Haas effect in Audion. If you have a speaking person who is being reinforced by a loudspeaker system, and the sound of a loudspeaker arrives considerably earlier than the sound of the speaking person, the human auditory system will perceive the localization of the speaking person as if coming from the loudspeaker. This is known as the precedence effect or Haas effect. In the following example, the listening direction is towards the speaking person, but the sound is perceived as coming from the loudspeaker.
Maître Corbeau sur un arbre perché tenait en son bec un fromage. Maître Renard, par l'odeur alléchée, éteint à peu près ce langage. Eh, bonjour, monsieur du Corbeau, que vous êtes joli, que vous me semblez beau. Sans mentir, si votre ramage se rapporte à votre plumage, vous êtes le phénix des hôtes de ces bois.
However, by introducing delays and adjusting the levels in a loudspeaker system, it is possible to reinforce the speaking person while maintaining the sound localization in the direction of the person. In this example, the speaking person is still being reinforced by the loudspeakers. However, the sound is perceived as coming from the speaking person.
Maître Corbeau sur un arbre perché tenait en son bec un fromage. Maître Renard, par l'odeur alléchée, éteint à peu près ce langage. Eh, bonjour, monsieur du Corbeau, que vous êtes joli, que vous me semblez beau. Sans mentir, si votre ramage se rapporte.
From now on, I will refer to the speaking person as the primary source and the loudspeakers as secondary sources. According to the Haas effect, the sound from a secondary source can be up to 5 decibels higher than the primary source and still achieve localization towards the primary source, so long as the sound from the secondary source arrives at least 15 milliseconds later. For a specific acoustic setup, Audion can calculate the required delays and levels to achieve a sound reinforcement and the desired localization at the same time. This function is available in Audition's Auditorium and Combined. First, you should have a job defined, with the primary and secondary sources all active. Then, in the source receiver list, click on Calculate Haas Delays and Levels. Here, you first select the job for which you want to calculate the delays and levels. Next, you select the primary source who will be reinforced by the loudspeaker system, for example, the speaking person. The receiver height refers to the distance from the floor that the listener's heads will be. To explain the need for this near zone radius parameter, imagine that your head is only 1 centimeter from the loudspeaker. In this case, Audion will have to calculate a very low gain so that you still localize the primary source from the correct direction. But in consequence, the sound from the loudspeaker will be very weak and will not contribute much to the sound reinforcement. To avoid this, your listeners should be at least some distance from the loudspeakers. So, the near zone radius is a radius around the loudspeakers where you don't expect to have any listeners. Specifically, the near zone radius defines a cylinder around the secondary source. Within this cylinder, proper localization will not be achieved, instead perceiving the primary source as coming from the loudspeaker. But again, this won't matter because no listeners are expected within this cylinder. Instead, Audion will maximize the gain of the loudspeakers while still achieving the localization outside of the near zone radius. For example, if you expect the listeners to be at closest 2 meters horizontally from the loudspeakers, you can enter a near zone radius of 2 meters. Audion will internally define Haas receivers, which are the calculation points Audion will use to calculate the delay and levels for each secondary source. These will be placed along the near zone radius, at a distance from the floor equal to the receiver height, and on the axis of the secondary source's orientation. Here, you can specify the level and delay of the secondary sources at the Haas receivers. For a good localization, we recommend to keep the defaults of 5 decibels and 15 milliseconds. Due to the spectra of sources and absorption curves of materials, the levels and delays will depend on the octave band, and it is not possible to calculate levels and delays for all octave bands at once. Therefore, here, you select which octave band to focus on in the calculation. Finally, you can tick this checkbox if you want Odeon to actually add the HAS receivers to the receiver list. This is simply a visual indication of the minimum distance required from the secondary source to achieve the desired localization. To perform the calculation, simply close the window and confirm. You will see that the secondary sources now have an overall gain and a delay. Only the primary source is unaffected. Now, the primary source will be reinforced by the loudspeaker system while keeping the localization towards the primary source. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!